Hi everyone. This series of videos is going to take you through the next lesson in the new packet, which is page 5 and page 6, more practice with sequence notation. As a reminder, you can access these pages through the learning plan because you don't have a physical copy of the packet, and you'll need to be able to follow along with the problems. So do make sure that you have the problems available either on a printed page or on a screen that you have open with a regular piece of paper in front of you so that you can follow along with what I'm doing. The goal today is basically to practice a little bit more using the ideas established in the previous lesson, which is how to understand writing geometric and arithmetic equations. As a reminder, on page 3 in the previous lesson, we had examples of arithmetic equations and geometric equations that we kind of used as a template, and you might want to consider writing down those equation structures so that you have something that you can refer back to. If you printed the actual packet, you probably noticed that I included a cover page the same way that all of our traditional in-class packets use, and this might be a good place to record those two equation structures so that you have something you can always refer back to. If you don't have this, you can always write it on another sheet of paper, but this might be a good time before we actually start the lesson to quickly just make sure that we remember what arithmetic equations look like versus what geometric equations look like so that we have something that we can use going forward. An arithmetic equation typically starts with t of n equals, and then it has two really important features. The first important feature is its initial value. Then we have plus, which could also be minus depending on whether you have a positive or a negative pattern, increasing or decreasing, for example. Then we have an adder followed by n. So the initial value is always the number that we say is the zero term in a table. It's always the number that kind of starts us off. And then the adder, or if it's negative, subtractor, I guess you can call it, is always the number that makes the pattern go. It's the number that makes us get to the next one and the next one and the next one. The n is a standard size n, so I put a little dot to show that n is technically multiplying whatever the adder is, but it's just a formality. You'll just put the letter n and you won't do anything fancy to it. It's just a letter. That's always part of the equation. A geometric equation is really similar in structure. It's also going to start with t of n equals. It also starts with an initial value, so that's actually a commonality that we can be prepared for. That's actually something that we can expect to always see. But this time, instead of a plus or minus, because you're not adding anything, so plus signs don't make sense, you use parentheses to show that you are multiplying. In fact, the number that you're multiplying by we call a multiplier, just like the number that we're adding by is called an adder. And then we use a power of n in order to show that we have a geometric pattern. The contrast to arithmetic should be pretty obvious. The arithmetic has a regular size n, geometric has a power n. So notice smaller font, and the power looks like it's lifted up as an exponent as opposed to the regular style n that we saw before. So just in order to differentiate these a little bit, you can see that the idea of the initial value is consistent. The initial value is always the zero term, no matter what. So that's why I highlighted both of those in that same yellow. But multiplier versus adder, that kind of depends on the nature of the question you have. If you have an adding pattern, then you have an arithmetic, and you're going to look for an adder. If you have a multiplying pattern, you're going to look for a multiplier. So those two things very rarely are the same, and that's why we want to think of them as different, hence the different colors. Now, keep this idea, and maybe if needed, take a screenshot of this if you don't have any way of writing it down for yourself, so that way you can refer to these structures when we actually do the problems on page 5. This video is going to walk you through the beginnings of page 5, and just like we do in most of our other videos, I'm going to have a kind of back and forth structure set up where I'll do some examples, you'll do the next things on your own, and hopefully with the answer key you can kind of fill in some of the gaps that the videos don't cover. We'll start with question number 1. Question number 1 says to consider the following sequence, and they're giving us a sequence of numbers. Unfortunately, they're not giving us a table, but they're telling us to fill in a table, so we'll definitely make sure we do that. The first and most important thing when we see a sequence is to ask ourselves what makes those numbers go together. What must be the pattern that connects 8 and 32 and 128 and 512? If we think logically, we only have two real options here. It's either adding or multiplying. I know that because the numbers are getting quite big. So adding numbers makes things bigger. Multiplying numbers makes things bigger. We just have to use a little bit of common sense to think which one makes more sense. If we think about adding, 8 plus 24 is 32, but plus 24 would leave me way short of 128. And plus 24 is definitely not big enough to get me to 512. So I don't think it's adding. Let's try multiplying. 8 times 4 is 32. 32 times 4 is 128. 128 times 4 is 512. Looks like we found the pattern. It looks like the pattern really is times 4. Now, in case you're not sure, guess and check is usually completely fine. Just try some stuff. Try some stuff till you find the pattern. It's rarely going to be a tricky pattern. It's rarely going to be such a weird number that you wouldn't have thought of it. But you might have to guess and check a few different numbers until you land on the one that's actually going to work. So we know that the pattern is multiplying by 4, which means we can immediately start to apply a vocabulary term. We know that this must be a geometric pattern because it is multiplying. And that use of vocabulary is something you'll hear me definitely rely on. So you might want to write those words as we say them. This is a geometric pattern. Now in letter A, it says, recall that the initial value is the number before the first term given in the list. Explain why the initial value of this sequence is 2. They're telling us that the initial value is 2. Let's make sure we understand why. I didn't make a table for this problem, but it might be helpful to think of it in terms of a table so we can make that connection. Let's think logically. 8 was literally the first number that they gave us in this problem. The first number is always n equals 1. 32 was the second number that they gave me in the list. So that means n equals 2. Notice first number, n equals 1. Second number, n equals 2. So the third number must be n equals 3. The fourth number must be n equals 4, and so on and so forth. It seems strange that we would have to make that assumption, but hopefully common sense kind of kicked in. If I give you a list of things, the first one in the list naturally seems like item number 1. So that's why hopefully this list idea makes sense. When I translate that into my table then, the first term, n equals 1, is my 8. So notice where I put the 8. The second term is 32. The third term is 128. The fourth term is 512. So that looks like it makes sense. But you see how there's that big empty space there where the 0 term is? They didn't give me the 0 term. They started off with the first one. So I have to think backwards for a moment. What number would have been in this missing spot so that when I multiplied it times 4 and kept the pattern going, that it gave me 8. So think, something times 4 would have made the pattern work. What number must it have been? Well, it must have been 2, because 2 times 4 is 8. Now, some people would have argued, oh, well, you could just go backwards. If you want to go backwards in the pattern, just divide by 4 and divide by 4. So 8 divided by 4 was 2. And that makes perfect sense. You can do it whichever way. Just take some time to explain in your own words why the initial value is 2. I've just explained it in my words, so I suggest that you pause the video for as much time as you need to write out something in your words that makes sense for letter A. Once you've filled out something, then letter C is going to ask you to once again revisit some vocabulary. Is a sequence arithmetic or geometric? We already established that it's multiplying by something, so that means it's geometric. And I'll just circle the letter G there to show that. Now in question letter D, it says, consider the expression T of 4. Notice how I pronounced that there, T of 4. What do you think this expression refers to? Well, the T seems to always be referring to the bottom row of the table. So I'm going to infer then that the T of 4 must be describing something in the bottom row, because that's where I see the letter T in this problem. The 4 is inside the parentheses, and I can tell that the 4, if it's inside the parentheses, must have something to do with this letter N. So this is where I'm going to use a bit of common sense. If I usually see in this table T of N, and I'm going to assume that that n is a 4, it looks like I can infer that that must be talking about the 4th term in the table. If n is 4, then I'm going to look at the top row for a second and say, oh, n is 4. Oh, here. So if t of n is the bottom row, and the clue is telling me which top term to look at, my instinct is to look at this 512 and to think to myself, okay, they must be referring to the 512 somehow. Now, in case you're thinking differently, here's another way you might have realized that they were talking about the 4th term. Remember, 1, 2, 3, 4 terms from the original thing that they gave us? The first term was 8, the second term was 32, the third term was 128, so the 4th term is 512. Well, this must just be referring to the 4th term. So that fancy thing that you see there, t of 4, is just basically saying the 4th term. So t of 5 must be the 5th term. T of 1 would be the 1st term. T of 3 would be the 3rd term. So when it says what is the value of t of 4, the actual value is the term in the bottom row. The actual value of t of 4 is the number in the 4th space. So we'd have to think logically about letter F. What's the value of t of 5? My table doesn't go that far, but t of 5 must be talking about the 5th term in the table. So let's think about the pattern. I have to extend the pattern a little bit further to know this. If I know that the pattern is times 4, 2 times 4, 8 times 4, 32 times 4, 128 times 4, the next term must be 512 times 4, 2048. That must be the 5th term. So that seems to make sense. That seems like it's working for us. Now, what about letter G? It says the number 8192 is one of the terms in the sequence. Determine the value of n such that t of n equals 8192. That's fancy sounding, but all that means is if we kept going, in other words, and I'll use some scratch paper to extend my table, if I kept going, that implies 8192 is going to show up somewhere. Let's see if we can keep going and see where we end up with 8192. Remember, if I keep going, I just mean keep multiplying by 4. So 512 times 4, now 2048 times 4. Ooh, turns out I didn't have to go far. There's my 8192. It's the 6th term. So in letter G, where it says the number 8912 is one of the terms, determine the value of n, that's just saying which term number is it? Oh, it's the 6th term. N is 6. So some of the vocabulary here is definitely a little bit different than what we're used to, but hopefully you're taking some time to make some sense of it. If you feel you understand this vocabulary well enough, I'm going to ask you to try question number 2, because question number 2 is very similar to what we just did. If you don't feel confident, then the next video will go over question number 2. But see if you can try it for yourself, just so you can give yourself a little bit of opportunity to explore a bit. And again, if you don't feel confident, you can use the answer key and you can use the next video and you can walk through number 2 with something to guide you.